Today I'd like to show you how we can use Pascal's triangle to expand binomials. Now Pascal's triangle is this pattern of numbers that you see here at the left. You'll notice that all of the outside values are ones, so every row starts with the number 1 and ends with the number 1. And on the inside, if you pick any two cells and add them together, you get the cell that's below them. So 15 plus 20 makes 35, or 28 plus 8 makes 36. So those are just a couple of the patterns that you will find in Pascal's triangle. It's actually a pretty cool thing. Now, what we're going to use Pascal's triangle for is expanding binomials. Now, by expanding binomials, we're talking about something like x plus y to any power. I'm going to just put n to generalize it. So we're going to use Pascal's triangle to help us find the coefficients of the values in the expansion of x plus y to the nth. Now let's say, for instance, we would like to find x plus y to the 4th power. To be able to use Pascal's triangle, we need to know which row to use. And what we are looking for is the exponent. So the exponent of 4 tells me that we're going to use row 4. So really, that's what these row numbers represent, is the exponent that's on a binomial. And that should make sense, because if you are talking about row 0 with an exponent of 0, we know anything to the 0 power is just 1. Or row 1, that would just be x plus y to the 1st, and you would have 1x and 1y, etc. So when we go to row 4, I can see that the values of the coefficients are going to be 1, 4, 6, 4, 1. Now, hopefully you can see that there's 5 terms in our answer to a 4th power. Same thing happens for 3. If I'm raising something to the 3rd power, I end up with 4 terms. Or if I'm squaring it, I have 3 terms. So there's always going to be one more term than whatever that exponent is. So just keep an eye out for that and make sure you have the right row. All right, so x plus y to the 4th, I'm going to have these 5 numbers as my coefficients. So I'm going to go ahead and start my 5 terms. I know the first term will have 1 as a coefficient, and then 4, and then 6, and then back to 4, and back to 1. And again, that's just those numbers in row 4. Now for the rest of the terms, I need to just recognize patterns in my exponents. If I'm raising x plus y to the 4th power, then my first term is going to have x, or the first thing in the binomial, raised to that biggest power, x to the 4th. And then as we continue to multiply this out, the exponents on the x decrease. So it was x to the 4th, then x to the 3rd, then x to the 2nd, then x to the 1st. And I'm going to go ahead and put in x to the 0, even though we know that's just 1, just to show the pattern. Now for the y term, or the second term in the binomial, it's going to start at nothing. So again, I'm going to go ahead and put in y to the 0. So basically there is no y in that first term, because again, y to the 0 is just 1. But it increases as we work through our terms. So second term would have y to the 1st, and then y to the 2nd, and then y to the 3rd, and then it finishes up with y to the 4th. So basically, I have done all the multiplication just by using the patterns here. Now, one other thing I do want you to recognize, as we look at each individual term, the exponent total for each term should match the original value of the exponent. So when we take the 4 and the 0, I can check to make sure that it's 4. And 3 and 1 for my second term, it also equals 4. And 2 and 2 make 4, etc. Okay, so just another little check that you can make to make sure that your exponents are looking good. So then the last thing we have to do is just simplify this a little bit. Fill in pluses and minuses. Everything here in my binomial is positive, so I know all of my terms will stay positive. Okay, and then I can just go back and kind of write this in a nicer way mathematically. Because for instance, in this first term, I don't really need to put the 1 as my coefficient. And I don't really need to put y 0 because I know that's just 1. So my first term is really just x to the 4th. The second term, again, I don't need to put y to the 1st. I can just write this as 4x cubed y. Third term, nothing really I can do to that. So I'm just going to write it as 6x squared y squared. Fourth term, I'm going to keep the 4 and make it just xy cubed. And then in the last term, again, I don't need the 1. X to the 0 is just 1, so I can write that as y to the 4th. And there we've used Pascal's triangle to get our coefficients, and then patterns for the x's and the y's, and we have expanded x plus y to the 4th.